Hey, Future Medics. Today we are breaking down the electron transport chain. And we did it. You made it. We are at the last step, the final step of cellular respiration. And I know you understand it now. You're doing so great. So let's finish this up strong. The electron transport chain takes place in the inner membrane of the mitochondria. And that's where the large amount of energy production is going to happen. Now, just like the Krebs cycle, this is an aerobic event. Aerobic needs oxygen, heavily dependent on it. And everything that we have done up to this point is going to come together into something beautiful. During the Krebs and glycolysis steps, we created products that still held on to a large amount of energy. So those products are put on the conveyor belt and they are taken to the inner membrane of the mitochondria. And here they're lined up and they start sharing electrons. There's a process of a ton of reactions. I hope you never have to know them all. There are so many, but what's important is what we get out of them. So they start transferring electrons and we're moving down, we're moving down, we're moving down. And through this, we're able to create 34 ATP. Now, I've seen this number anywhere from 28 to 34. So go with whatever your book says and what your professor says. 34 is a very efficient system. But we're going to go with 34. I pulled out my paramedic book. That's what it says. I got in the books for you. I was very determined to make sure I got this right. So we create, through these reactions, 34 ATP, which is insane. When you look at the Krebs cycle, we made 2. And in glycolysis, we made 2. And then we jumped to 34. So per every 1 molecule of glucose, we end up with 34 plus 4, 38. There you go. That's a lot. 38 ATP. Crazy payoff. That's amazing. Now we can live and digest, and our brain works and our heart works, and we can still go running for fun. Like, that's a lot of energy. That's fantastic, right? This is only if oxygen is present in the cell. Have to have it, or it doesn't happen. This is why aerobic metabolism is so important. This is why oxygen is so important. This is why perfusion is so important. Because you saw in glycolysis how we didn't get a lot of product. In the Krebs cycle, we did not get a lot of product. But in electron transport chain, we do. We get a huge payoff. But steps 2 and 3 completely cease to exist if we don't have the oxygen to accept those electrons at the end of the chain. This won't happen. So now you understand how important oxygen is. Now in ETC, we do still get a little bit of waste. It's usually heat, like that's usually how it is dispersed. We don't usually see like a lot of lactic acid from this step. We're seeing like a little heat transfer, which is fine. But this is why we teach you airway, breathing, circulation. This is why it's so important, because if oxygen does not make it all the way to that mitochondria, this huge payout, it just can't happen. That's it. That's it. You did it. You understand. I know you do because you're smart. You're fine, right? So now hopefully this was broken down a little simpler to where you're like, yes, totally, that all fits together. That's the entirety of cellular respiration. I am going to make another video for you about aerobic versus anaerobic respiration because it is important in other things as well. But for the 3 steps, thrice, of cellular respiration, this is the end of the road. So you did a great job. I know you're going to continue doing a great job. I know you're working hard. Yeah. I'll see you soon. I believe in you. Even if you don't believe in yourself right now, I know you can do it. See ya.